So we're going to talk about equations of tangent lines. So let's just think for a minute about this problem. Suppose f of x equals the function 1/4 x squared. Okay? And we say find f prime of 3. So that means we're going to take the derivative first and then plug 3 into the answer. So that's what these instructions are saying. So let's find f prime of x. Well, we can use our power rule. So 2 times 1/4 is 1/2 x to the first power, because when I subtract 1 from my exponent, it becomes 1. So this is the slope of the tangent line to the curve for any x value. Okay? But I want it when x equals 3, so I do a half of, oops, that's a mistake there. Hold on a minute. I do a half of 3, and I get 3/2. Now, I guess what I want to do is reinforce what that means, and then show you something else clever that you can do that you might not have known. All right? So this 3/2 means the slope of the tangent line to this function at x equals 3 is 3/2. So we can actually draw a picture of that function pretty easily. Here's x and y. We know y equals a half x squared is a parabola, and the 1/2 makes it a little bit wider than usual, so maybe it looks something like that. Okay? And we've just shown that when x is equal to 3, that the slope at that point of the tangent line, that slope, is 3/2. Okay. So I just want to go one step further. My claim is that we can find the equation, not just the slope, but the equation of the tangent line to f of x equals 1/2 x squared at x equals 3. That we can actually find that. And here's why. Because here's the line that I'm interested in, that line right there. And I already know something about it. I know its slope. So I can write this down. I can say y minus y1 equals m times x minus x1. And I can write y minus y1 equals 3/2 x minus x1. All right, so we're left needing to know these two things, but we actually know one of them right away. We know x is 3. So I can fill that in. So y minus blank equals 3/2 x minus 3. And the only thing left to get is y1. Well, if I think about that, here's the point I'm interested in. I know that x is 3. To get the y value there, I can just plug into the function. So y equals a half of 3 squared, which is 9/2. So the coordinates at this point are 3, 9/2. And that means I could put 9/2 here. And then you're done. That is the equation of the tangent line to the parabola y equals a half x squared at x equals 3. Okay, small mistake. This should have been 1/4. I just copied that wrong, so if you're confused, I'm sorry. And this should have been 1/4, so this would have been 9/4. Oop, small mistake there. Sorry about that. All righty. All right. So let's try another one. So suppose f of x equals, I'll be more careful this time, 3x squared plus 11x minus 12. And we say find the equation of the tangent line at x equals 2, maybe. Okay? So if we just think about the equations of lines for a minute, y minus y1 equals m times x minus x1. It's the point slope form of a line. All you need to know is what point does the line go through and what slope does it have. Okay? So we can get the slope by taking the derivative. So f prime of x would equal 6x plus 11. Okay. And then we can plug 2 into there. Well, we do that. F prime of 2 is going to be 6 times 2 plus 11, or 12 plus 11, or 23. So now we at least have the slope of our line, so we can write that down. Y minus blank equals 23 x minus blank. So we can put 2 here right away because we knew we wanted the tangent line at x equals 2. So we have that part. So the last thing left to find is, hey, what's the y value there? But you'll be okay if you remember what the original function does. This original function here tells us the y value, that's what y is over here, whenever you sub in something for x. So if you plug in a number for x, you'll get the y that goes with it. So really what we want to know is what's f of 2, or what's the y value when x is 2. So a little bit of calculations here. 3 times 2 squared plus 11 times 2 minus 12. Be careful with this. 2 squared is 4. Do that first. 4 times 3 is 12 plus 22 minus 12. Oh, that's sort of nice. You just get 22, right? So there you go. So the y value that we needed is 22. And there's the equation of your tangent line.